So I just want to remind you that you have a quiz tomorrow. That quiz will include everything in your packet from page 17 until the end of the packet, which is all on law of superposition, putting stuff in order based on its age, including questions very similar to these here on page 32, which included index fossils and using index fossils to help you figure out how old different layers are. So this was a perfect example of some things that might be on the quiz tomorrow. So we'll go through page 32 through the end. It says, the geological cross-section below shows an unconformity in New York State bedrock layers that have not been overturned. Index fossils found throughout some rock layers are shown. Which New York State index fossil may have been present in the rock layer that is missing due to an unconformity? So first you got to remind yourself of what an unconformity is. Does anybody want to volunteer what an unconformity is? If no one volunteers, I'm just going to call on people. Thank you. Yes, so if you flipped back to page 22, an unconformity is a buried erosional surface. It's always represented with a wavy line. So there's that wavy line I was talking about. It is, most importantly, it's a gap in the geological record. It's really a missing part of the record. It's a whole missing layer, and it's caused by extreme erosion. So what would have happened, the best way I can describe an unconformity is we had this layer here. We had the layer on top of it with polka dots. We had a brick layer. And then on top of that was some unknown layer. What happened to this unknown layer that I just drew? Yeah, so either a glacier came through, or waves came through, or a river came through and erased it. So it removed it, and it left behind some evidence, such as a U-shaped valley or V-shaped valleys or striations, or all sorts of those things. And that's represented with the wavy line. Then what happened on top of that wavy line? Later on in history. So after the glacier came through and left behind the wavy line, new stuff got put on top of it. So in this case, a layer of sandstone. And in this case, that layer of, oh, that's got the dots, so a layer of siltstone. That's how unconformities work. A whole layer gets erased. The key is we don't know what got erased. We don't know what kind of rock it was or what fossils were in it. But you can use the rock layers around it for some clues. So they're saying which one of these four guys or characters could have been in that layer that got erased. So how can I go about figuring out what could have been erased? How'd you do this one, guys? How do you figure out what could have been erased? You want to know? You could look at the timeline. Which timeline? You mean this one? Okay, exactly. You're going to look at the timeline. They gave you some hints. The hints are these index fossils. And I know it's hard to see on mine up here, but you can see that there's a dinosaur up here at the top. And that dinosaur is this dinosaur down here. It's letter L. I like to label this so I don't have to think of it later. And then we got this thing, to me, I have no idea what that actually is, but it looks like a paintbrush to me. And that's letter H. So again, I'm going to label it. So they're saying, how old, actually, let me ask you guys this. How old is the unconformity compared to those letters? So I can call on anybody to do this one because this is easy. Carlos, how old is the unconformity compared to H? So the wavy line compared to H, younger or older? Yeah, it's younger because it's on top. Yeah, I'm sorry. It's younger because it's on top of H. And Brennan, compared to L, what is it? Yeah, it's older than L. So it's somewhere between L, and H. Now there's a lot of fossils that come in between L and H. And now again, make sure you're not looking at the order down here. I'm not asking what's in between H and L on the bottom. I'm talking about on the actual timeline. So the best way to do this is process of elimination. So we've got answer 1 is a condor, which is letter S on the bottom. Is S in between L and H? Did S come in between L and H? No, S is really young. So that couldn't have been in there. That wouldn't have been erased. How about 2, this fish creature, which is R? Could that have been in between L and H? Yeah, here's R right here. So it's in between. H happened about 420 million years ago. L happened about 200 million years ago. R happened in between that at about 360. Just double check the rest of the answers. Did this letter T happen in between? No, that's older. And how about that squiggly thing, which is W? Is that in between? No. So the only one that fits in between those 2 layers is that fish guy. Another way you could have done it is you could have gone and said, okay, H. So this is kind of what I did anyway. H was about, use the reference table, figure out how old, 420 million years old. L was about 220 million years old, and then go find how old these guys are. S is still around now, so it's 0 million years old. R is about 360 million years old. T and W are about the same age, and they are about 480 million years old. So now that I know how old each one is, I can see only one would fit in between 220 and 420. This will be on the quiz tomorrow. All right, during which geological time period was rock C deposit? Oh, wait, let me read the words because that's the #1 rule. Base your answers to 42 through 45 on the diagram below, which represents 2 bedrock outcrops, 1 and 2, found several kilometers apart in New York State. Rock layers are lettered A through F. Drawings represent specific index fossils. So they're saying they're both in New York State. They're about a few kilometers away. So it's like saying this one was found in Arcade and this one was found in Delavan. By saying that, you get the idea that they have they're close. So they have the same climate. If one was covered by an ocean, the other one was covered by a deep ocean. The only difference is maybe a river washed away some layer in one spot. Maybe they dug down deeper in another spot, kind of that deal. So now it says during which geological time period? So when they say time period, they're talking about the periods on the reference table. Was rock layer C deposited? What's in C that's going to help us figure out how old it is? There's a fossil. And in fact, which fossil is that? That's fossil A. So even though it's layer C, don't look for fossil C. You got to look for that particular fossil, which does match up with fossil A. So you find A, you read over till you get to the period, and that's the Cambrian period. Identify 2 processes that produce the unconformity. Well, we know one off the top of our heads. What makes an unconformity? Erosion. And when you have erosion, what's its best buddy? Can't have erosion if you don't have weathering. Weathering and erosion created the unconformity. Describe one characteristic a fossil must have in order to be a good index fossil. Well, there are 3. Give me one of them. Kelvin, what's one thing you have to be a good index fossil? Question 44. Perfect. So they got to be widespread. So found all over the place. Brennan? Easy to recognize. And there's one more. Anybody got it? Mhm. Well, that actually doesn't make it a good index fossil. No, there's 3 characteristics that make, because that's just any fossil. A good index fossil is widespread, easy to recognize, not lives a long life. Okay, actually, I want to make this clear. When you say short lifespan, I will accept that, but make sure you know that that doesn't mean that these guys were only, like, they only had a short life, but in general, they only lived for a short geological time, or only found for a short geological time. Which means they were only around for a very brief time period. So you probably just didn't finish your sentence. Alive for a short period of time. Again, you only needed one of these, but make sure you know all 3. This will be on the quiz tomorrow. Notice I did not say abundant. I saw a lot of that on the lab. Guys, what does the word abundant mean? A lot of them. None of these say a lot of them. It's similar to widespread, but being found widespread doesn't mean there's a lot of them. It just means that they're found everywhere. So don't use the word abundant. And like I said, I should not have included question 45. If you answered it, boy, I'm curious how you did it. Google. All right, 5 more questions and then we're going to start something new. It says base your answers to questions 46 through 50 on the geological cross-section below and your knowledge of earth science. The cross-section shows New York State index fossils in rock layers that have not been overturned. Rock unit A is an igneous intrusion and the line XY represents an unconformity. So we've got some rock layers. We have an intrusion. There is some rock layer, or there's some unconformity. And we have these fossils. And in case you don't know what they are, they name them here. And they actually even give you a key for the rocks here. So they didn't need to do that, but they did. All right, so it's based on the fossil evidence during which geological period, based on the fossil evidence, determine the geological period during which the unconformity formed. Same deal. They want to know how old this is. How can we figure out how old it is? Okay, again, we go back to the timeline. We know when these fossils are from because index fossils are basically a timestamp. You know exactly if you find this fish, which again is letter R, fish, letter R, we know that R, what period is that R from? It's from the Devonian. So I'm just going to label it so I don't have to think. So if the fish is from the Devonian, then that entire rock layer is from the Devonian. And then this thing, which I have no idea how to pronounce that word, but that's letter I. Find letter I. When is letter I from? Also from the Devonian. So we know the unconformity is older than the fish, younger than that feather duster thing. But both of them were during the Devonian. So during what period did that unconformity form? Also during the Devonian. Identify, for question 47, the coral index fossil. So we're looking for an index fossil. So that means we're down here at the bottom. But we want one that's a coral. Coral is a whole one of these lines. So our answer is going to be one of these 3 that existed, or that would be in the same layer as this guy, that same feather duster thing, letter I. So you go to I, you go over to the corals, and then you see that's V. But don't write V. I need the actual name, which is a horrible to pronounce word, but you can just copy it right off the reference table. C, or no, not C. P-L-E-U-R-O-D-I-C-T-Y-U-M. Again, you're not supposed to know those words off the top of your head. Just copy it from the reference table. So that's a coral that was around at the same time as that CTEN word. All right, we already did the index fossils once, but it says they existed for a short geological time interval. State one other characteristic that it must have to be considered an index fossil. So there are three. They gave you one. What's another one? Widespread. And the other one? Easy to recognize. You only needed one, but make sure you know all three. Ooh, do you know what they even mean by type of depositional environment in which these fossilized organisms lived? Do you even know what that means? It means, where did all of these fossils live when they were alive? Take a look at the fossils. What kind of organisms do you see? What is this thing? It's a fish. We've got some shells, some sort of thing. Where do fish and shells usually live? In water. So you could have answered this by water. The Regents will use the phrase marine. I think, if you guys all saw the word marine, would you know what they mean? Marine means like a marine environment, like water. And then one more thing, state one piece of evidence shown in this cross-section that indicates that the intrusion is older than the sandstone. What you got, Brennan? No, contact metamorphism. Where is there no contact metamorphism, by the way? Right, on the sandstone. Perfect. So like I said, the quiz, you'll need to know how to do that stuff. You'll need to be able to, like we did yesterday, see one of these cross sections and answer questions about them. I will not make you put them all in order like we did for homework. But again, you got to be able to answer questions about it. So you basically need to know how to put them in order to answer questions. And then just make sure you know these vocab words. So you need to know the index fossil, unconformity, that kind of stuff. Here's some more practice questions if you need to review. And then make sure you know all these vocab words on 17. So 17 through the end of the packet on the quiz tomorrow. In the meantime, we are going to kind of start something new. We're not going to do too much though. Can you guys turn to page 9? But before we start on page 9, what do you have on the page that comes right before that? Is it a blank sheet of paper? No, it's not. Ugh, I screwed up. So you remember when I said I forgot to print a whole page? Yeah, well, I also forgot the back of that page too. So what I would like you guys to do, if you do not have a blank page, so those of you who have the non-double-sided one, you'll be fine. No, yeah, so those of you who only have one-sided packets, which I see, do you have one-sided packet? Wait, where do you have that's blank? What do you show me the next? Oh, you're good because yours is only one-sided. Are there any blank pages around here for those of you who have a double-sided packet? Where? Yeah, I think we did already. All right, so those of you who have the double-sided packet, take your packet, grip it in your hands like this. gonna pause this for a second. All right, so on this new sheet of paper, which we are putting in between page 8 and page 9, I would like you to title it Absolute Time. Guys, what do you remember about absolute time? What do you remember about absolute time? We did it, the very first thing we did this chapter. Gives us an exact date or time. Remember, I said my birthday, April 5th, 1983 was an absolute time. Saying I was born in 1983 is still an absolute time. Saying I was born in the 80s is still an absolute time. Or as some of you have referred to it as the late 1900s is also an absolute time. It's just, it doesn't have to be like right on the second. It just has to be a specific unit of time. To figure out absolute time, we use a thing called radioactive dating. When I say radioactive, what comes to your brain?
Radio.
Okay, so like the radio, but not quite. How about radioactive? Radiation. When you get chemotherapy, they put a radioactive drug in you. What else uses radioactive stuff? Radioactive. What? How about nuclear stuff? A nuclear bomb, a nuclear power plant is radioactive. Yes. Yep. Exactly. So we know some dangerous radioactive stuff, but we also know chemotherapy and radiation is, yes, it's helpful, but those of you who know anybody who's ever gone through those treatments, it kills the cells with the radioactive treatment. So it's good, but it hurts the body as well. So radioactive, it's nuclear stuff we're talking about here. Now, not all radioactive things are harmful. There is some radiation that is just background radiation that does not hurt you. There's a few vocab words that we are going to need to talk about. So we're going to start talking about, we'll start with the term half-life. Half-life. Half-life is, some of you have done half-life in math class already. If you have already done it in math, they made it harder than it needs to be. I'll make it easier for this year. So half-life, as the name implies, it talks about something about half of the life. But really what it is the amount of time it takes for half of the radioactive isotope to decay. And right away, we're going to need to talk about what an isotope is. Great. So half-life, the amount of time it takes for half of the radioactive substance to decay, or half the time it takes for a radioactive isotope to decay. What's an isotope? It's not anything you probably have done yet. It is an unstable element. Now you should remember elements. They're the guys over here on the periodic table. There's different versions of, let's say, carbon. There's carbon 12, 13, and 14. Everybody's stable except for carbon 14. What do you guys get when I say unstable? If I said somebody in this room was unstable, what would you think they are?
Mentally unstable.
Okay, what does that mean to you?
They're gonna freak out.
They could freak out at any moment. At any moment, we could lose them. They're gonna have a breakdown or freak out or whatever. The same thing with these elements. Unstable elements are not safe and happy where they are. They like to change. And so isotopes, there's different ones, but the radioactive ones are unstable elements. And I guess this is as far as this class is getting today. So that's it. You do have your quiz tomorrow, don't forget.